Kia ora. This video follows on from Surds 4, where we learnt something called rationalizing the denominator. So we don't ever want to have surds left in the denominator. So when we have a simple surd like 2 divided by root 5, we multiply the top and the bottom by root 5. And this leaves us with 2 root 5 divided by 5, which is much more elegant. Suppose that we have 1 plus 1 divided by root 3. What happens if we try multiplying the top and bottom by the surd part? Well, it doesn't really work. We get root 3 on top, and in the denominator we're left with root 3 plus 3. So we haven't made things much better. To work with problems like this, we need to have a new idea, which is the idea of a conjugate. The conjugate is going to help us rationalize the denominator. And the conjugate for 1 plus root 3 will be 1 minus root 3. Okay, so if we have a surd, a plus the square root of b, its conjugate is a minus root b. Let's have a look at why this is going to help us. So if we've got 1 over 1 plus root 3, we're going to multiply the fraction by 1 minus root 3 over 1 minus root 3. So we form the conjugate, write it in the denominator, and then write it in the numerator. We haven't changed the value because we're just multiplying this by 1. Okay, now remember, way back to year 10 or 11, that there are invisible brackets here. Okay, so it's actually quite useful to pop them in. What's going to happen in the denominator? Well, we'll just do FOIL as usual. So the 1 times 1 gives me 1 minus root 3 plus root 3 minus 3. And in the numerator, in this case, it's very easy. It's just 1 minus root 3. Okay, make sure that you're writing this down and following along as I go. So I'm just going to squeeze this in here. What we've got here is we've got 1 minus root 3 in the numerator. And look what's happened in the denominator. I've got minus root 3 plus root 3, so my surds have gone. And I'm left with 1 minus 3, which is negative 2. Okay, so I still need to do some cleaning up, but it's lovely because I have managed to get rid of the surds in the bottom line. Because what we're doing here is we're really creating a difference of two squares situation. Okay, so we'll go on to the next slide and we'll fix that example up a little bit. This is pretty ugly in that form. Okay, so we've got 1 minus root 3 on negative 2. Right, so I can rewrite that. I can multiply top and bottom by negative 1. And I get root 3 minus 1 divided by 2. Okay, so what I've done there is I don't want to have the negative sign here. So I multiplied top and bottom by negative 1. So that one now looks very nice. So root 3 minus 1 over 2. So that was question 1 from Delta 28.6. I'm going to do 3 more questions. I'm going to do question 4, question 11, and just let me see what the next one is. Question 4, 11, and question 21. So you might want to pause the video now and have a go at those yourself, and then follow through. Okay, question 4, 1 over 4 minus root 3 equals 1 over 4 minus root 3. Now I'm going to form the conjugate. It's 4 plus root 3 times, so 4 plus root 3 Right? So in the numerator, we're going to have 4 plus root 3. In the denominator, pop your brackets in, just while you're getting used to this. 4 fours are 16, minus root 3 times 4, plus root 3 times 4, so they add up to 0, minus 3. So I get 4 plus root 3 over 13. Question 11 is 5 root 3 over 2 root 3 plus root 2. So we're asked to simplify that. So it's 5 root 3 over 2 root 3 plus root 2 times the conjugate 2 root 3 minus root 2 over 2 root 3 minus root 2. So notice that here I've actually got something a little bit more complicated. I haven't got a rational number here either, but this method is still going to work. So we form the conjugate by taking the first number minus the second number. So let's look at the denominator. So I've got 2 root 3 squared. The plus here matches the minus here, so those terms are going to disappear to 0, minus 2. Right, and now in the numerator I've got 2 root 3 times 5 root 3, which is 10 times 3, so 30, minus 5 root 6. So in this one here, 2 root 3 squared is 2 times 2 times root 3 times root 3. Okay, I'm doing that just out here. So that's 12 minus 2. Numerator 30 minus 5 root 6. So we're going to go to a new slide to clean that up. So I've got 30 minus 5 root 6 divided by 10, which is equal to 6 minus root 6 divided by 2. So I'm taking out a factor of 5. Okay, so that's your final answer there. You could also write that one as 3 minus root 6 on 2. Either would be fine. Right, that was question 11. Next one I'm going to do is question 21. Root 3 over 1 plus root 5 equals root 3, 1 plus root 5 times 1 minus root 5. Numerator is root 3 minus root 15. Denominator is 1 minus 5, which equals root 15 minus root 3 divided by 4. Right, now I've sneaked 2 steps in there. What I'm doing there, just to save a tiny bit of space in the video, is I get a negative 4 out here. So I'm going to times the top and bottom by negative 1. Okay, if that last step didn't make sense, just ask me in class.